Hello students, in previous lecture we have studied about the nature of solution of electrolyte, different electrolyte like a strong electrolyte and weak electrolyte, the variation of molar conductivity with the concentration. Now in today's lecture we are studying about the Cole-Roche law. Now why the Cole-Roche law? In the previous lecture I have told that for strong electrolyte we can find out the molar conductivity at infinite dilution using the extrapolation method. Means we get the graph linearly. That is why we can extrapolate the graph and we can find out the molar conductivity at infinite dilution. But for weak electrolyte we cannot find the molar conductivity at infinite dilution because we get the graph of lambda versus root c is a curve. So that is why we cannot find out the lambda 0 value, that is the molar conductivity at infinite dilution. For that we can see the Cole-Roche law or Cole-Roche law. Using that we can find out the molar conductivity at infinite dilution for a weak electrolyte. Now first we will see the statement of Cole-Roche law. Now Cole-Roche law, I will write here, the Cole-Roche law states that at infinite dilution or we can say that at a zero concentration, at infinite dilution each ion migrates independent of its co-ion, and contribute to total molar conductivity, of an electrolyte See here Cole-Roche law states that at infinite dilution each ion migrates independent of its co-ion and contribute to total molar conductivity of an electrolyte irrespective of nature of other ion with which it associated. So I will explain the meaning of that. See, what is the first statement? The Cole-Roche law states that at infinite dilution, or you can say that at zero concentration, each ion means if you take up the electrolyte, in that cation and anions are there. So each ion migrates independent of its co-ion. Means the cation, it's a migration not depend on the anion, or the migration of anion not depend on the cation. Means each ion migrates independently of its co-ion and contribute to the total molar conductivity of an electrolyte. So molar conductivity of an electrolyte depends on the number of cations and number of anions. So it contributes to the total molar conductivity of an electrolyte irrespective of the nature of other ion with which it is associated. Means the molar contribution of cation depends on the nature of anion, or the contribution of anion is not depend on the nature of the cations, like this. So this is about the Cole-Roche law statement. Now from the statement you can say that the molar conductivity of the any electrolyte depends on the number of molar conductivity of cation and the molar conductivity of anion. So mathematically you can write it down the statement for Cole-Roche law like this. See, lambda 0 is equal to n plus into lambda 0 of cations, means the molar conductivity plus number of anion into molar conductivity of anion at infinite dilution, or you can say that at a zero concentration. Important point is that we have taken here lambda 0 for cation and anion also, and for total molar conductivity of electrolyte is also. Means at infinite dilution is very important. That word is very important. At infinite dilution, lambda 0, that is total molar conductivity of an electrolyte, it depends on the molar conductivity of cation and molar conductivity of anion. So here n plus is what? N plus will be the number of cations and n minus will number of anion. Lambda 0 plus will be the molar conductivity of cation, lambda 0 minus will be the molar conductivity of anion. So that is the mathematical statement for the Kohlrausch law. Now we will see the application of Kohlrausch law. First application of Kohlrausch law is we can find out the molar conductivity of any electrolyte by knowing the molar conductivity of its ions. Means, for example, see here, if you know the molar conductivity of K plus and Cl minus, we can find out the molar conductivity of KCl. See here, molar conductivity of KCl is equal to, what we get? Molar conductivity of K plus ion plus molar conductivity of Cl minus ion at infinite dilution. So first application is what? By knowing the molar conductivity of K plus and molar conductivity of Cl minus ion at infinite dilution, we can find out the molar conductivity of KCl, that is electrolyte, at infinite dilution. We will take another one example. Suppose you take a BaOH twice. How we can write it down the Kohlrausch law for that? See here. Lambda 0 Ba 2 plus lambda 0 OH minus. Now here OH minus, that is why here number of anions will be 2. See here, in statement we have taken n plus and n minus, that is number of cation and number of anion. For KCl, how it will ionize? K plus and Cl minus, means number of cation 1, number of anion 1. That is why here I have not written, only written lambda 0 K plus lambda 0 Cl minus. But BaOH twice will ionize as a Ba2 plus and OH minus. That is why here number of cation 1 and number of anions 2. So that is why molar conductivity of BaOH twice is equal to what? Lambda 0 Ba2 plus 2 into lambda 0 OH minus. So that is the first application. By knowing that values, means the molar conductivities of the ions, we can find out the molar conductivity of electrolyte. Now second application is very important. I have told that in a previous lecture that the molar conductivity for the weak electrolyte at infinite dilution we cannot find out from the graph by extrapolation method. So that is why Kohlrausch law is useful for finding the molar conductivity of the weak electrolyte. Now suppose we have to find out the molar conductivity of acetic acid. How we can use the Kohlrausch law? By knowing the molar conductivities of strong electrolyte, we can find out the molar conductivities of weak electrolyte from that. म्हणजे स्ट्रॉंग इलेक्ट्रोलाइटच्या जर आपल्याला मोलार कंडक्टिव्हिटीज माहित असतील तर त्याच्यावरून आपण वीक इलेक्ट्रोलाइटची मोलार कंडक्टिव्हिटी फाइंड आउट करू शकतो. हाउ वी कॅन फाइंड आउट? सी हियर. नाउ सपोज इफ यू वांट टू फाइंड आउट द मोलार कंडक्टिव्हिटी ऑफ एसिटिक एसिड व्हिच इज वीक इलेक्ट्रोलाइट. सी हियर we have to find what? Molar conductivity of acetic acid by knowing the molar conductivities of HCl, NaCl and sodium acetate. Three are strong electrolytes. We can find out the molar conductivity of acetic acid. Now I will tell here how it is possible. See here, suppose we know the molar conductivity of HCl. Okay, molar conductivity of HCl. We know that. How we can write it down the Kohlrausch law for that? Lambda 0 of HCl is equal to what? Okay, and if you know the molar conductivity of sodium acetate, that is CH3COO sodium acetate, how we can write it on the Coloros law for that? We will get lambda 0 CH3COO minus plus lambda 0 of Na plus. Okay, you can write it down Na plus first, or in this way also you can write it down. Okay, so from these three equations, suppose we write here, this is equation number 1, this is equation number 2, or this is equation number 3. Okay, from this equation we have to apply the mathematical operation on that. How we can apply? See here, CH3COOH acid, how it will ionize? It will ionize as a CH3COO minus and H plus. H plus is cation, CH3COO minus is an anion. Now, from that, for getting the CH3COO minus and H plus, we apply the mathematical operations on that. How we can apply? By adding the equation, means we have to cancel here Na plus, okay, and Cl minus. We want here only H plus and CH3COO minus. So how we can apply this? We have to add these two equations, means, or we have to apply first and third we have to add, and second one equation we have to do the subtraction of this second equation. So here see, I will write here, by adding equation 1 plus 3 and subtracting equation number 2. बघा इथे समजतंय का काय करायचंय? आपल्याला आयन्स कोणते हवे? CH3COO मायनस आणि H प्लस, आणि मग हे हवा असेल तर ह्याच्यातलं कॅन्सल काय व्हायला पाहिजे? Na प्लस आणि Cl मायनस. सो हाऊ वी कॅन कॅन्सल आउट दॅट? जर हे इक्वेशन नंबर 2 आपण सबट्रॅक्ट केलं तर इथं काय होईल? मग हे मायनस मायनस that will be cancelled to these two from equation, and you will get H plus and CH3COO minus. See, from adding equation number 1 and 3, I will write directly here. What you will get? Lambda 0 H plus plus lambda 0 Cl minus. Equation number 3 is what? Lambda 0 CH3COO minus, I will write here, plus lambda 0 Na plus minus, second equation आपण काय करतोय? मायनस करतोय. So that will be lambda 0 Na plus minus lambda 0 Cl minus. Now this Na plus will cancel plus minus, and this Cl minus will cancel plus minus. So you will get what? Lambda 0 H plus plus lambda 0 CH3COO minus, and this is nothing but what? Lambda 0 of CH3COOH, that is molar conductivity of acetic acid. Here Na plus plus minus and Cl minus plus Cl minus minus will cancel. Means remain what? Molar conductivity of H plus, molar conductivity of CH3COO minus, and addition of these two is nothing but what? Total molar conductivity of acetic acid. So by knowing the molar conductivities of strong electrolyte, here HCl, NaCl and sodium acetate, three are strong electrolytes. So by knowing the molar conductivities of strong electrolyte, we can find out the molar conductivity of weak electrolyte. Okay, so these are the two applications of Coloros law. Okay, so I hope you understood about the Coloros law. Depending on the Coloros law, we'll see on the problem. So depending on the problem, Kohlrausch law, we'll take one problem. I will write directly here given quantity. See here, we have to calculate the molar conductivity of CH2Cl COOH. Okay, we have to find the molar conductivity of this. If the lambda 0 values of HCl, lambda 0 of HCl is equal to 4.261. Its unit is ohm inverse centimeter square per mole or mole inverse. You can write it down like this. Then another one value HCl, similar to that, lambda 0 of KCl is given, which is equal to 1.499 ohm inverse centimeter square mole inverse. And third value is given, that is lambda 0 of CH2Cl COOK, which is equal to 1.132 ohm inverse centimeter square mole inverse. Okay, so these three values are given. We have to find out the molar conductivity of this. So how we can find out this? By using the Kohlrausch law. I have told that how we can apply this. First, now see here, this CH2Cl COOH, how it will ionize, that you should know. Okay, how it will ionize? You will get CH2Cl COO minus and H plus. So for getting these two ions, we have to apply the mathematical expression or mathematical operation on that, like plus minus on these three. First, we'll go stepwise. According to Kohlrausch law, we'll write for HCl, ACl and this CH2Cl COOH. Okay, so see here, according to now solution of this problem, how we can solve? According to Kohlrausch law, for lambda 0 HCl, how we can write it on the Kohlrausch law for that? Lambda 0 HCl is equal to what? HCl will ionize as a H plus and Cl minus. So that is why lambda 0 H plus plus lambda 0 Cl minus. Okay, so that is for HCl. Right here it will be the equation number 1. Now second, for KCl, how we can write it down? Lambda 0 KCl is equal to, KCl will ionize as a K plus Cl minus. So lambda 0 K plus plus lambda 0 Cl minus. Okay, and third, that is lambda 0 of CH2 Cl COOK. How it will ionize? That will be the lambda 0 of CH2 Cl COO minus plus lambda 0 of K plus. Okay, so this electrolyte will ionize like CH2 Cl COO minus and K plus. And number of cation, number of anions in these three electrolytes are 1. So that is why I have written directly. Now from these three equations, see, तुम्ही ह्या तीन इक्वेशन कडे बघितल्यानंतर जर तुम्हाला कोणते आयन्स हवेत CH2Cl COO minus and H plus, how we can get these two ions? इथं आहे हा एक आयन CH2Cl COO minus आणि H plus कुठे आहे या इक्वेशन मध्ये, म्हणजे कॅन्सल कोणते व्हायला पाहिजेत? K plus आणि Cl minus. So adding the equation number 1 and 3 and subtracting the equation number 2 from these two, you will get these ions. Okay, I will write here by equation number 1 plus 3. काय करावं लागेल तुम्हाला? इक्वेशन नंबर 1 आणि 3 ऍड करावं लागेल and subtracting equation number 2 from this addition, you will get your required result. Okay, so here lambda 0 H plus lambda 0 Cl minus. इक्वेशन नंबर 3 काय आहे lambda 0 CH2 Cl COO minus plus what lambda 0 K plus. Okay, and subtracting equation number 2, so minus lambda 0 of K plus minus lambda 0 of Cl minus. Okay, so now equation number 1 3 add केलं आणि 2 काय केलं सबट्रॅक्ट केलं. आता जी आपण इथं मॅथमॅटिकल ऑपरेशन्स यूज केले तर आपण आता काय करणार आहे त्याच्यामध्ये व्हॅल्यू ठेवणार आहे. काय केलं इक्वेशन नंबर 1 त्याचा मोलार कंडक्टिव्हिटी ऑफ HCl किती दिली आहे 4.261. मोलार कंडक्टिव्हिटी ऑफ KCl will be 1.499 and molar conductivity of CH2Cl is 1.132. Okay, so we have to put that value. From this what you will get by adding and subtracting you will get lambda 0 of H plus what lambda 0 CH2 Cl COO minus, and that is nothing but the molar conductivity of whatever electrolyte we have to given. Okay, so that is the ions of that given electrolyte for which we have to find out the molar conductivity. Okay, so whatever addition subtraction we have done that will do here, that will be the lambda 0 of what CH2 Cl COO H. Lambda 0 of this. So whatever mathematical expression done on these ions or molar conductivity we have to apply this for the values also. So equation number 1 म्हणजे HCl3 molar conductivity किती आहे 4.261 plus equation number 3 which we have applied for this CH2Cl COO molar conductivity is 1.132 and minus for KCl that is 1.499. So simply by addition of these two and subtracting 1.499 from that we will get the answer 3.894 unit काय आहे याचा ओहम इनवर्स सेंटीमीटर स्क्वेअर मोलर इनवर्स which is nothing but what molar conductivity of CH2Cl COH. So that is your final answer 3.894. Okay, so this is the problem based on the Polar's law. I hope you understood this problem. इथं महत्त्वाचं काय लक्षात ठेवायचं आहे तुम्हाला जो इलेक्ट्रोलाइट दिलेला आहे त्याची मोलार कंडक्टिव्हिटी फाइंड आउट